First two problems, you are supposed to find the coordinates of P prime if P and P prime are symmetric with respect to point M. What this basically means is you have a segment with endpoints P and P prime, and M is the midpoint. That's by definition of point symmetry. So what I would suggest, just to get your orientation, draw a segment. So here's where P is, here's where M is, and then here's where P prime is. And these are supposed to be the same length. Midpoint formula. Take the average of your x values, followed by the average of your y values. M, our midpoint, is 8, 7. One of our x values of our endpoints is 11. The other endpoint x value we don't know, so we use x sub 2. Our y1 is the y value of an endpoint, which is negative 3. Y sub 2 is the other y value of the other endpoint, which we don't know what that is, so we use a variable. Now at this point we're saying that 8 is equivalent to this fraction. 8 is the x value of the midpoint. This fraction here is also the x value of the midpoint. So you set them equal to each other. Get x by itself, multiply both sides by 2. Subtract 11, and you get x sub 2 is 5. Similarly, set your y values equal to each other. 7 is the y value of the midpoint. So is the fraction negative 3 plus y over 2. Multiply both sides by 2. Add 3 to both sides, and you get the y value is 17. So our ordered pair is 5, 17. Checking your answer is simple. What's the average of 11 and 5? What's the point that's right in the middle of those? Well, 5 plus 11 is 16, divided by 2, you get 8. For the y value, 17 plus a negative 3 is 14. 14 divided by 2 is 7. So we've done it correctly. Number 2, do it the same way. We have a segment. P is an endpoint. M is the midpoint. P prime is the other endpoint. Midpoint formula. Average of your x values, followed by the average of your y values. Midpoint is 10, negative 11. One of the x values of your endpoint is 0. The other one is x sub 2. The other is x sub 2. Our y values of our endpoints are 3 and y sub 2. So 10 we set equal to 0 plus x sub 2, which is just x sub 2, over 2. Negative 11 we set equal to 3 plus y sub 2 over 2. Here we multiply both sides by 2, and we get x sub 2 is 20. That's the x value of P prime. And then here, in this other equation, multiply both sides by 2. And subtract 3, you get negative 25. That's the y value of P prime. For number 3 and 4, you're supposed to determine if the function's even or odd, or if it's neither, and then circle the appropriate response here at the bottom. If a function is even, it's symmetric with respect to the y-axis. On the y-axis, you change the sign of the x value, you leave the y value the same. For a function to be odd, it's symmetric with respect to the origin. In that case, you change the sign of x and you change the sign of y. You do both of them. So, to see if it's even, take your function. Every place you see an x, replace it with a negative x. Every place you see a y, leave it as y. When you substitute, you are supposed to use parentheses. Simplify this. A negative x to the fourth is going to be a positive x to the fourth. A plus 2 times a positive x to the fourth is a plus 2x to the fourth. Over here, we have a negative x to the eighth. It's an even number of negatives, so it's going to be a positive x to the eighth. We're subtracting a positive x to the eighth. Does this look like the original equation? Yes, it does. Therefore, this is even. Let's check for audacity. So for odd, we replace x with negative x and replace y with a negative y. So negative y equals 8 plus 2 times negative x to the fourth minus negative x to the eighth. So it's a negative y equals 8 plus a negative x to the fourth is a positive x to the fourth. That times a plus 2 is a plus 2x to the fourth. Negative x to the eighth is a positive x to the eighth, but we're subtracting that, so we're subtracting x to the eighth. Trying to get this to look like the original, so multiply both sides by negative 1, and you will see this does not resemble the original, so it is not odd. Number 4, is it even, which means symmetric with the y-axis, which means you change the sign of the x value, leave y the same, or is it odd? It's symmetric with respect to the origin, you change the sign of x and you change the sign of y. So even, leave y the same, change x to a negative. When you substitute, you are to use parentheses every time, except when I don't feel like it. You heard me. A negative x to the third is an x to the third negative. So we have a negative x to the third, which is positive. Here we have a negative x to the fifth, which is going to be x to the fifth negative, and we're subtracting a 6 times that. So in essence, it's a 6 times a negative, which is negative. So it's a subtracting a negative, which is the same as adding a positive. Same as the original? No, it's not. This is not even. Odd. Change the sign of y, change the sign of x. Once again, the same as it was over here on the left. Negative x to the third is a negative x cubed. A negative x cubed is a positive x cubed. Negative x to the fifth is an x to the fifth negative. So a negative times a positive 6 is a negative, subtracting a negative, adding a positive. Multiply each term by negative 1 to get y by itself. That's the same as the original. You know it. So this is odd. It's pretty odd, I'm not going to lie to you. For each parent graph, describe the transformations that take place in the related graphs of each function. Previously, I had told you to always do stretching, shrinking first, reflections second, and then translations third. And I'm actually wrong if it is an inverse. For example, number 5, the parent function is y equals x squared, and a is plus or minus the square root of x, which is the inverse of this function. If it's an inverse, you should actually do the reflection first, stretching and shrinking second, translating third. If you're graphing an inverse, you should do the reflection, stretching and shrinking, and then translating. So on number 5a, first thing that's going to happen is this graph is reflected over the line y equals x. Second thing that happens, stretch vertically by 6. Third thing that happens, the graph is translated up 4. B, similar. This is the inverse of this parent graph because the parent graph is x squared. This is the square root plus or minus the square root of x. So it's reflected over the line y equals x. This 0.5 shrinks the graph vertically by 0.5. This minus 2 translates the graph to the right 2, and this plus 7 translates it up 7. Number 6 says the graphs below are portions of complete graphs. Sketch a complete graph for each of the following symmetries. So first thing I would do is, so I don't forget, so this is part of the graph. I need to have a complete graph. So to do that, I need to make sure that this part is here for each of these graphs. So I'm going to put this on here. Just going to do all that at the beginning so I don't forget it. Some students forget it. A says symmetric with the x-axis. So here is the x-axis. If this is reflected over it, it would be down here. So the yellow and the black together make the complete graph. B is the y-axis. So if this black ray is reflected, it would be over here. It's the same distance from the y-axis. The red and the black together make the complete graph. C is the line y equals x, which looks a little something like this. if this was reflected over that, it would look like this. Let me show you how I know that for certain. If I pick any point on this, the first part, and I draw a segment that hits the line of symmetry at a perpendicular, I should be able to continue that segment at the same angle, perpendicular, and the same distance, and give me a point on this other part, which that obviously does. If you do that twice, you only need 2 points to make a segment. 90 degrees, 90 degrees, same length, same length. You can see, hopefully that's how I got that. Part D, the line y equals negative x, that symmetry is here. Y equals negative x. And the rest of this graph is going to be like so. 2 reasons. One, I can visualize it if I reflect this black part of the graph over the line of symmetry. 2, if I do the same thing that I did here for y equals x, pick any point, draw a segment to the line of symmetry at a perpendicular, and then extend it. I didn't draw it exactly perpendicular, but you can see it should be here. Do the same thing with another point. Any point that's on the line of symmetry will be on the other part of the graph. So I got those 2 points, connect them, and finished. 7 and 8. Determine where the graph of each equation is symmetric and with respect to the, determine where the graph of each equation is symmetric with respect, this should say whether, not where. Determine whether the graph of each equation is symmetric with respect to the origin, x-axis, y-axis, the line y equals x, or y equals negative x. You can have more than one answer. This is supposed to be a squared. This is supposed to be a cubed. Origin. For the origin, you're going to use a negative x and a negative y, and for x and y. For the x-axis, you're going to use an x and a negative y. For the y-axis, you're going to use a negative x and a y. For the line y equals x, y is x, x is y. Y equals negative x, you got negative y and negative x. Same is going to apply to this next problem, so I'm just going to copy this down here. So, for the origin, you're supposed to put a negative y in for y, negative x in for x. A negative y squared is y squared. A negative x cubed is x cubed negative. Subtracting a negative is like adding a positive. Is this the same as the original? No. It's not symmetric with respect to the origin. X-axis. Make y negative. Leave x the same. A negative y squared is y squared. This is the same as the original. Therefore, this graph is symmetric with respect to the x-axis. The y-axis, you leave y the same. Put a negative in for x. A negative x cubed is an x cubed negative. Subtracting a negative x is going to be like adding a positive x. Not the same as the original. So this is not symmetric with respect to the y-axis. This next one, you're supposed to interchange x and y. You're probably screaming right now. There's no way this one's going to work. You're right. It's not. In fact, I don't even know if I can get this to resemble the original. If I try to get y by itself, I could subtract x from both sides, or subtract 1 from both sides. Divide both sides by -1. Clearly, this is not going to work. You need to carry it out as far as you can. Don't just say, no, it doesn't work. Y equals -x, you're going to get the very similar result here that we just got. -x squared is x squared. -y cubed is a y cubed negative. Subtracting a negative is like adding a positive. And once again, it's just NGH. Not going to happen. So this graph is symmetric with the x-axis and nothing else. Number 8, origin. Make the x negative and make the y negative. It's going to give us -y equals 2x squared over 5. A negative x squared is positive. Getting y by itself, multiply both sides by -1, you get this. Not the same as the original, therefore the origin doesn't work. X-axis. You'll see this one doesn't work either. Put a negative in for y, leave x the same, get y by itself by multiplying both sides by -1. Not the same as the original. Doesn't work. Y-axis. This one's going to work. Leave y the same, change x to a negative, simplify it, and you get y equals 2x squared over 5, same as the original. Next one, interchange x and y. This one's not going to work either. If you get y by itself, multiply both sides by 5 halves. Square root both sides, you get plus or minus the square root of 5 halves x equals y. Not the same as the original. This last one, not going to work either. -x equals 2 times the -y squared over 5. If you multiply, a couple things, -y squared is positive. If you multiply both sides by 5 halves, you get -5 halves x equals y squared. Square root both sides, and you get plus or minus the square root of -5 halves x equals y. Sorry that's so tiny. Doesn't work. You really should write legible. Number 9 here, we're supposed to sketch the graph of the function. Since this resembles a parent graph, this should be pretty simple. This 3 is going to stretch the graph vertically, which means it's going to be much skinnier than the original. The -1 translates the graph to the right 1, and the +2 translates it up 2. So I'm going to go right 1, up 2. Always label that point. And then it's going to curve up like this, just like the parent, but it's skinnier than the parent. And it curves down like this. So it's this basic shape is what it is. So what else do I have to do? I mean, that's all the work you got to show for that. You should find the X and Y-intercepts. And once again, at this point, I said you're allowed to use your calculator. I'm not going to do that because I am not a weak person. I'm not weak-minded. You heard me. To find the Y-intercept, we're going to put 0 in for x. then simplify it. 0 minus 1 is negative 1. Negative 1 cubed is negative 1. 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. So the y-intercept for this graph is negative 1. I knew that ahead of time. That's why my graph looked like that. But if you don't label your x and y axis, it doesn't really matter where it crosses as long as it's someplace close and you label it as being that point. What about the x-intercept? To find the x-intercept, we're going to put 0 in for y and get x by itself. Once again, you're allowed to use your calculator if you want. Eventually we're not going to use it, so I like to not use it myself unless I have to. I'm going to subtract 2 from both sides, divide each side by 3, take the cube root of both sides, and add 1 to both sides. This is the x-intercept. If I then put that into a calculator and want to get an approximation, which I prefer the non-rounded answer, but this is approximately 0.1. So my x-intercept is approximately 0.1. That's it. Graphing it was real simple. Finding the x and y-intercepts took some work or took some pushes of your calculator. Number 10. This is the parent function of y equals the absolute value of x. I should have mentioned here on number 9, this parent graph is y equals x cubed. This is y equals the absolute value of x. You should know what that looks like. If you don't, and you're in quite the pickle right now, because that's something that was expected for you to know from beta 2, I believe. So what's happening here? Well, this 0.3 stretches the graph, shrinks the graph vertically by 0.3, which makes it get much fatter. So instead of being like this, then maybe it's more like this. This negative reflects the graph over the x-axis, so now that it's shrunk vertically and it's pointed down instead of up, this plus 2 moves it to the left 2, and the minus 4 moves it down 4. So the vertex was at 0, 0. Since we went left 2 and down 4, it's perhaps in this location. It opens down instead of up because it was reflected, and this graph is a bit fatter than it was originally. As you can see, there's no x-intercept. Doesn't cross the x-axis. To find the y-intercept, you have permission to use your calculator or just do the algebra. It doesn't take that long. Put 0 in for x to find the y-intercept. Zero plus 2 is 2. Absolute value of 2 is 2. 2 times negative 0.3 is negative 0.6. Negative 0.6 minus 4 is negative 4.6. It's the y-intercept. Once again, you could have used your calculator for that. So that's number 10. 11 and 12. Determine any horizontal, vertical, or slant asymptotes in the graph of each function. To do those things, you need to factor. So looking at this enumerator, it doesn't factor. We have an x to the fourth as the first term, and x cubed as the second, and the last term doesn't have any x's in it. So this is not going to factor. I'm just going to write that down. Can't factor. To find vertical asymptotes, take your denominator and you set it equal to 0. If you divide both sides by 5 and then cube root both sides, you get x is 0. So this is the vertical asymptote. To find horizontal, you compare n to d. N in this problem is 4, d is 3. N is the biggest exponent in the numerator with respect to the variable. D is the biggest exponent in the denominator with respect to the variable. So comparing n to d, 4 is bigger than 3. If n is bigger than d, then there is no horizontal asymptotes. Slants. Slants can happen only if n, I'm going to write this up here because I didn't leave you much space, if n is exactly 1 more than d. So is 4 exactly 1 more than 3? It sure is. So we have a slant asymptote at y equals something. To figure out what that is, we take our enumerator, x to the fourth minus 7x cubed. I'm missing some terms here. I'm missing an x squared. I'm going to put 0x squared. I'm missing an x. I'm going to put a 0x plus 1. Dividing that by 5x cubed. Let's look at this closer. Pun. Give myself more room. Once again, I apologize that the space that you have on your paper is less than adequate, and that is putting it nicely. First, need to decide how many times will 5x cubed go into x squared. To determine that, if you simply take the first term, x to the fourth, and divide it by the first term what you're dividing by, 5x cubed, and simplify it. You lose all the x's on the bottom, you have one left on the top. So this is 1/5 x. Then multiply 1/5 x times 5x cubed, and you get 1/5 times 5 is 1. X times x cubed is x to the fourth. You then change the sign of that and add. That cancels. Since that cancels, that means that's correct. Bring down the next term, negative 7x cubed. How many times will 5x cubed go into that? Let's check. What's negative 7x cubed divided by 5x cubed? Here your x's cancel completely. You're left with a plus negative 7/5 or a subtract 7/5. Your choice. I'm going to go with subtract. A subtract 7/5 times 5x to the third. 7/5 times 5 is 7. Negative times a positive is a negative. X cubed times, well, 1 is x cubed. Change the sign and add. It cancels. At this point, if we bring this down, and this down, and this down, the exponents that are left are less than the exponents we're dividing by. Therefore, everything that's left, which is truly just this 1, is a remainder. So the slant asymptote is y equals however many times it goes into this evenly, which is 1/5 x minus 7/5. So this, let me write this a little bit nicer. So the slant asymptote is y equals 1/5 x minus 7/5. This is just a linear equation. Has a y-intercept of negative 7/5. It's a little bit more than negative 1. Has a slope of 1/5, up 1 to the right 5. Number 12, let's see if this bad boy factors. going to get in here a little bit tighter. Y equals. This numerator is a perfect square trinomial. Here's how I know. This first term is a perfect square. This last term is a perfect square. If I take the square roots of those two, so that would be x and 2, and double it. Once again, take the square root of the first term times the square root of the last term, and then I double it. If that's the same as the middle term here, then it's a perfect square trinomial, which this is. To factor a perfect square trinomial, you take the square root of the first term, put it in the first spot, take the square root of the last term, put it in the second spot, take the sign of the middle term and put that between. It's a plus, and that is squared. Perfect square, that's where the square comes in, trinomial. The denominator has a GCF. If I factor out that GCF, I get x squared minus 4. X squared minus 4, that is a difference of two squares. Let me tell you how I know that. First of all, it's a difference. We're subtracting. That's easy. Second of all, it's called a difference of two squares. Is x squared a perfect square? Yes. It's a square that is x by x. Is 4 a perfect square? Sure, it's a square that is 2 by 2. 2 times 2 is 4. Difference of two squares. It's not a joke. If it's a difference of two squares, you take the square root of the first term and put that in the first position. Square root of the second and put it in the second position. You make 1 plus and 1 minus. Then, anything that will cancel, you should cancel. When things cancel, you should be screaming at your monitor right now, whole. This question does not even ask you to find holes, but you should be so attuned to when you cancel things off to scream whole at the top of your lungs. Your mom should be yelling at you, get down here for the meatloaf, but she's distracted and can't say it because she hears you say, whole. Anyhow, so what we're left with here is y equals x plus 2. We get rid of one of those. There was 2 on the top. Over 3 times the difference of x and 2. This is what's left. This is what you use to find your asymptotes. You don't use the x plus 2 that you crossed off. That's a whole. So how do you find the vertical asymptotes? Take your denominator, set it equal to 0, and solve it. And divide both sides by 3, add 2 to both sides, and I get x is 2. A different way to do this, I should mention this in case you're just going to do it the exact way that I showed you in your notes, which is probably the best way. This is already factored. Set each factor equal to 0. 3 equals 0 and x minus 2 equals 0. 3 equals 0. That is not true. Therefore, there's no solution from this because 3 doesn't equal 0. Here, if you add 2 to both sides, you get x is 2. These are just two different methods. We'll call this method 1, and we'll call this method 2. That's method 1 because that's how I did it in the notes. So we have a vertical asymptote at x equals 2. Horizontal. Let me zoom out here so we can see this a little bit better. To find horizontal, you're going to compare n to d. Now n and d can be, you have two options. You can pick the n and d from the original, 2 and 2, or you can pick n and d from what's left, which is 1 and 1. It doesn't make a difference. It does not make a difference. Nada matter. 1 is equal to 1. Hence, we have a horizontal asymptote at y equals a over b. What is a? What is b? Well, if I take this and multiply that 3 out, which probably should happen to do this part. A, it's A over B. A is the leading coefficient in the numerator, it's a 1. B is the leading coefficient in the denominator, which is a 3. So y equals 1/3. Also, from the original problem, it's a 1 and a 3. So, also 1/3. If there's a horizontal, there's no slant. Let me just show you the work for the slant to prove that there isn't one. Is n exactly d plus 1? N is 1, d is 1. Does 1 plus 1 equal 1? No. Whence, no slant asymptote. Number 3, you're supposed to create a function of the form y equals f of x that satisfies each set of conditions. Number 13 has a vertical asymptote at x equals -2 and a hole at -2. So a couple things you have to do. One, for each of these problems, it's always going to be, always, f of x equals a fraction. There are no exceptions. If you have a vertical asymptote, then that information is going to be put on the bottom. If you have a hole, that information is going to be put on the top and the bottom. So here we have a vertical asymptote at x equals -2. So working backwards, and this is work you do not have to show. Working backwards to find vertical asymptotes, we took our denominator, set it equal to 0, and solved it. We don't know what that denominator was. But we do know when we solved it, we got x equals -2. If you work backwards, in other words, get 0 by itself, you have to add 2 to both sides. So that means if you have x plus 2 equals 0, that means x equals -2. So the bottom of our fraction must have an x plus 2 in it. You do not need to show this work. If there's a hole at x equals -2, that means we had to set x plus 2 equal to 0 so that when we solved it we got 2. That means we had to have an x plus 2 on the top and the bottom. To distinguish between these two, let me color code. This hole are the green binomials. This vertical asymptote is the yellow binomial. That's it. Number 14, same directions, so our answer is going to be f of x equals fraction. It's always f of x equals a fraction. There are no exceptions. If you have a hole at x equals 0, that means you had to cancel from the top and the bottom an x. If you had a hole at x equals 8, that means you had to cancel from the top and the bottom an x minus 8. If it resembles y equals x squared, as a fraction, x squared is x squared over 1. So you put x squared on the top, don't need to put 1 on the bottom because it's redundant. Here is your function. Once again, to color code, resembles y equals x squared is this part. A hole at 0, -3. Oh, I've skipped the -3, so I'm not finished. There's a hole at 0. That's this part. There is a hole at x equals 8. That's this part. And the one that I skipped over when I was reading, x equals -3, it means there's a hole at x. I keep saying that wrong. If there's a hole at x equals -3, that means there has to be an x plus 3 in my fraction. An x plus 3 on the top and an x plus 3 on the bottom. The order of these terms, the order of these factors do not matter. So color coding, there's where those things come from. 15 and 16, find the inverse of each function. Sketch the function and its inverse. Is the inverse a function? Circle yes or no. First of all, this is supposed to be a cube, and it doesn't look like it. To graph this, it's ridiculously easy if you know your parent graphs. The parent equation for this is y equals x cubed, which looks like this, with this point here being at 0, 0. This minus 2 takes that and translates it to the right 2. This plus 2 translates it up 2. Therefore, the curve is going to look something like this. This is the function y equals the difference of x and 2 cubed plus 2. Should label this point here as 2, 2. Need to find this x-intercept, which we'll do in a moment, but right now let's graph the other function. Let's also graph the inverse. Without even knowing what that inverse is, we should be able to graph it. It's the same graph that you see here reflected over the line y equals x. Here's the line y equals x. So the same graph reflected over that line y equals x is going to look like this. It's the same graph reflected over that line. Now if you need to do it in pieces, you can. This is the parent. If it's reflected over the line y equals x, then it's going to look like this. And then the vertex, well, I mean, you can do it in pieces. That's not the way I like to do it. Just for me, mentally, it doesn't work out as easily. If you have to do it in pieces, you need to find this inverse first. So only thing left to do is find the inverse. Is the inverse a function? Is the inverse a function? Is this black curve a function? It certainly is. Need to find these x and y-intercepts, and then I'll find the inverse, the actual function. To find the x-intercept of this red function, I've given you permission to use your calculator. Once again, for me it's quicker and easier to not. Hopefully you feel the same way. Put 0 in for x, that's to find the y-intercept. Oh well, let's find the y-intercept then. Put 0 in for x. 0 minus 2 is negative 2. Negative 2 cubed is negative 8. Negative 2 plus 2 is negative 6. So the y-intercept of the red function is negative 6. That means that the x-intercept of the blue function is negative 6. They're inverses. X's and y's are in different locations. The x-intercept for the red function, I'm using red for the red function, put 0 in for y and get x by itself. If I subtract 2 from both sides, and then cube root both sides, and then add 2 to both sides, I get 2 plus the cubed root of negative 2. That is approximately 0.7. So this x-intercept here is approximately 0.7, which means the y-intercept for this black curve is 0.7. So the graph is finished. I've got some work here. You don't have to show this work if you want to use your calculator. Just make sure you do it correctly. And the last thing to do is find the inverse. I haven't even found it yet. I didn't have to find it to graph it because I know what the graph is reflected over the line y equals x. To find the inverse, replace x with y and y with x. Get y by itself. So the inverse is the cubed root of x minus 2 plus 2. So once again, if you need to graph this using the inverse, here's how you would do it. You would say reflect the graph over the line y equals x, because it's the cubed root, translate it right to and up to. So once again, this black curve, if we reflected it, oh boy, it's not together. Let me put it together. If we put this together, oh, and I grabbed that. Holy shnikes. Sorry, you're not going to get that 30 seconds back from your life. Anyhow, this is the original curve, that red one reflected over the line y equals x, the parent graph. And then you translate it to the right 2 and you translate it up 2, and that puts you here. Number 16. I'm going to do it in the same order. I'm going to graph this because it's a parent graph. I know what that looks like. It's the parent graph parabola, which vertex is at the origin, translated down 1. So it looks something like this, and this is the not beautiful version of it. That reminds me, I forgot something over here. You're supposed to label each of these. So this red curve we labeled as this. The black curve I should label with the inverse, which is the cubed root of x minus 2 plus 2. And it gets to a point where there's so much information here, it looks awful. I apologize for the awfulness of that. But I think all those things are important. So if this is what this looks like, and this vertex is at 0 and -1, the inverse is going to have a vertex at, you switch these around, at -1, 0. And it's reflected over the line y equals x. So this curve is going to look like this. Something like that. I don't even know what that function is, but I know that's what it looks like. I know that's not a function. This red doesn't pass the vertical line test. Let's find out what that function is. Now let's first find the X-intercepts for this black function. I know what the Y-intercept is. To find the X-intercepts, I put 0 in for y and get x by itself. Add 1 to both sides, square root both sides, I get plus or minus 1. That's my X-intercepts. Which means the Y-intercepts for this other curve is 1 and -1. Which I already have that labeled. I'll label it again at the same point. Don't need to label it again on second thought. Let me get rid of that. Let's not unnecessarily cluster this. So what is the inverse? To find the inverse, we take the function we're given, interchange x and y, and then get y by itself. So f inverse plus or minus square root of x plus 1. Label my curve with that, and we're finished. I don't know if that fit on the screen. Let me move this over a little bit just in case it didn't. Dunsey. Number 17, graph two relations on the same coordinate plane. Determine if the two relations are inverses. Circle yes or no. If the answer is no, write an equation of the inverse of the first equation. Well, this here, first one, we'll call this the yellow one. That graph resembles the parent graph y equals x squared. This plus 3 translates it to the left, 1, 2, 3. So the curve looks like this. -3, 0. Probably should have not used yellow. Let's change that to green. See if it looks better. And I didn't change it to green, I just pretended to. And I changed my axes to green. Looks like I dumped a lime Kool-Aid all over it. Alright, what about this other curve, which we will do in blue? Y equals plus or minus the square root of x minus 3. This plus or minus square root was going to make the graph look like this. And then the minus 3 translates it to the right 3. So it looks a little something like this. I don't want to get off to the side here, so I'll pull this back a little bit. Also, don't want that to be yellow. Make it blue. So this x-intercept, this vertex also is 3, 0. Are these inverses? Here's a quick way to tell, or a quick way to know that they're not for sure. Look at your vertices. If this vertex and this vertex are the same, but in the opposite direction, in other words, this is -3, 0, this one should be 0, -3. It's not the case, not inverses. If you draw the line y equals x and reflect it, they're not on top of each other. So the answer to the question, no, they're not inverses. Should also find this y-intercept. If I put 0 in for x, I get 3. 3 squared is 9. On your test, your quiz, whatever you want to call it, each set of directions hopefully will tell you if you have to find the x or y-intercepts. If it doesn't, ask your teacher. Your teacher will tell you. So the direction said, if they're not inverses, write the inverse, that is the inverse of the first equation. So my first equation is the green one, so I have to find its inverse. It was y equals the sum of x and 3 squared. To find the inverse, interchange x and y. Get y by itself. So my inverse is going to be y equals plus or minus the square root of x minus 3. That's the true inverse. 18, this graph here is, the parent graph is x cubed. This minus 3 moves it down 3. So it looks something like this. That's just epic fail over the place. Let me try this a fourth time. Something like this. It's important that you label your vertex in the right location. Also, I'm not going to find the X and Y-intercepts for the rest of these. Just to save time, you can do the same here for your practice quiz. This graph here is reflected over the line y equals x. So it's going to look like this. And it's translated up 3. So that's what you see here, and it's up 3. So the vertex is 0, 3. And we'll call this yellow. That's red. That is not yellow. So are these inverses? I should label these once again. I didn't do this on 17. I color-coded them, so I guess that's good enough. On your paper, if you don't have yours color-coded, label these graphs. I'm going to color-code these so I don't have to do that. This is my blue one. This is my red one. Are the inverses? No. If I look at the line y equals x, these are not reflected about that. Also, this vertex is not the interchange of this one. If I interchange x and y, I don't get that one. So they're not inverses. If they're not, what is the inverse of the first function? My first function was y equals x cubed minus 3. If I interchange x and y and get y by itself, I would add 3 to both sides and then cube root both sides. So this is the inverse. Y equals the cubed root of x plus 3. Y equals x squared minus 5. X squared is a parabola. That's what the parent looks like. This minus 5 translates that graph down 5. Let's say this is down 5, so we get 0 and negative 5. Of course, this graph is going to extend like so. Pardon the ridiculousness of that curve. It should be much smoother. Probably just making it worse. That's this one. The other one is plus or minus the square root of x plus 2. Plus or minus the square root is going to look like this. It's reflected over line y equals x. This plus 2 translates that graph to the left too, making its vertex negative 2, 0. Are these inverses? They are not. Several reasons why they're not. Once again, if you look at the diagonal y equals x, these are not mirror images of each other. 2, another dead giveaway. This vertex is negative 2, 0, which means the red vertex should be 0, negative 2, which it's not. If they're not inverses, you're supposed to find the inverse of the first function. The first function was y equals x squared minus 5. To find the inverse, interchange x and y. Square root both sides. So we get y equals plus or minus the square root of x plus 5. That's the inverse. Number 20, for the parent graph, describe the transformations that have taken place and then sketch the graph. Well, this 0.2 shrinks the graph vertically by 0.2. this negative reflects the graph over the x-axis. This minus 4 translates the graph down 4, translates it right 4, and this plus 5 translates it up 5. Should be noted, I gave you D spaces to put your answer. That was random. There could be more than D, there could have been less than D. So this graph started out looking like this. If it was shrunk vertically, that means it now looks more like this. If it's reflected over the x-axis, now it looks more like this. If it's translated right 4 and up 5, then it looks more like this. With that vertex then being 4, 5. If on the test you're asked to find the Y-intercept and the X-intercept, you could use your calculator or you could do the work yourself. If you're asked to find the Y-intercept, put 0 in for Y, in for X, and simplify it. Zero minus 4 is negative 4. Absolute value of negative 4 is 4. Negative 0.2 times 4 is negative 0.8. Plus 5 is 4.2. X-intercept, plural. Put 0 in for Y and get X by itself. And I'm not going to do that right now because it just takes too long. You get negative 21, you can use your calculator. And the other one is 29. I take it back, I'm going to do it. Put 0 in for Y. Get X by itself. When solving an absolute value, get what's inside the absolute value by itself. I'm going to subtract 5 from both sides. Then I'm going to multiply both sides by 5. Why would I multiply both sides by 5? 1, I'm crazy. Another, I know that I'm going to multiply both sides by negative 5. Makes that a plus 25. I know that 0.2 is the same thing as 2/10, which is like this. 2/10, get it? Someone's camping, 2/10. No, wasn't funny, sorry. My bad. It wasn't funny, you're an idiot. Sorry. 2/10 reduces to 1/5. So to get rid of a times 1/5, you can multiply by 5. That's why I did that. Once the absolute value is by itself, you make two separate equations. One where you just remove the absolute value. The other where you remove the absolute value and you change the side that didn't have an absolute value to a negative. So instead of 25, it's negative 25. Solving each of these, I get 29 and I get negative 21. So those are my x-intercepts. Sorry I said I wasn't going to do it because it was important that I did do it. All right, number 21. We should always factor before we do anything else. And I hope that you didn't hear what I just heard, because it was largely inappropriate. If I factor my denominator, this is a difference of two squares, which factors into an x minus 8 and an x plus 8. We can cancel the x minus 8s. As soon as you do canceling, you should write down whole, and you should take whatever you canceled and set it equal to 0. There's going to be a hole in the graph at x equals 8. That's the x value. There's also has to be a y value. To find the y value, take what's left of your function. What's left is y equals 1 over x plus 8, comma, there's going to be a hole. Just reminding myself so I don't forget. So I take my function y equals x plus 8 under 1, and I replace the x with an 8, because that's the x value of my hole. My hole has an x value of 8. 8 and 8, 16, so my hole is 8, 1/16. So to graph this, I look at this 1 over x plus 8. I know what the parent looks like, so this requires little to no work to graph. This plus 8 translates the graph to the left, 8. So my vertical asymptote, instead of being at 0, is at negative 8. Y equals negative 8, vertical asymptote. My horizontal asymptote, move left 8, you would not be able to tell. My curve, which resembles the parent, then looks like this. The only thing left to do, well, there's two things left to do. One is where this hole is, 8, 1/16. Mark on my curve, hole, 8, 1/16. The other thing is to find the y-intercept. Anytime one wants to find the y-intercept, simply put 0 in for x into what's left of the function. So that's y equals 1 over 0 plus 8, which is 1/8 is my y-intercept. It's also your y-intercept. Finished. So 22, once again, factor. All these problems start out with the potential of factoring it. If it can be factored, you should do it. I can cancel the x's. As soon as you cancel something, you should shout from the rooftops, whole. Set it equal to 0. Solve it. Already solved. X value of your hole is 0. To find the y value, take what's left of your function, y equals x minus 2, but there's a hole at 0 something. Take what's left of your function and replace the x value with the x value of your hole, which in this case is 0. So we have a hole at 0, negative 2. So we are simply graphing a line, y equals x minus 2. Has a y-intercept of 0, negative 2, has a slope of 1. So it looks like this. But there's a hole at 0, negative 2. So we find that, and we put a hole in the graph, and we label it 0, negative 2. The only thing left to do for this is the X-Intercept. To find the X-Intercept, put 0 in for y and get x by itself. X-Intercept is 2. (23) As always, if it has factoring to do, factor it. X squared minus 16 is the difference of two squares, which factors into an x minus 4 and an x plus 4, both binomial factors. Denominator also factors. can factor a -1 out, leaving you with x plus 4. The x plus 4's cancel. When things cancel, you must scream, hole! Hole! Whatever you cancel, just set equal to 0 and solve. We have a hole at -4. That's the x value. You must also have a y value. Take what's left of your function. Y equals x minus 4 divided by -1, which is actually x equals y equals -x plus 4, but we have a hole. This is also a line. Put the x value of your hole in for x. We get y equals 4 plus 4, which is 8. So we have a hole at 4, negative style, 8. Graph it. It's a linear equation. Y-intercept is at 4. The slope is -1. So it looks like this. It's just a line. Nothing more, nothing less. We have a hole at -4, 8. Let's say that that's right here. X-intercept we need to find. Put 0 in for y into what's left and get x by itself. So it's 4. Dunsies.